So here we'll be working with both cosine and also sine as well, yeah? And we're going to let u equal to sine x. So if we let that equal to sine x, first thing we want to do is differentiate it. So differentiation of sine x, du on dx equals to cos x. Flip the two, so dx equals to du on cos x. Let's substitute them in now, but we have to always see how these limits there, just be really careful, always remember those. So put in pi on 4 into this equation over here, okay? So u equals to sine of pi on 4, and that's going to be 1 on square root 2, yeah? Whereas sine 0 equals to 0, so these are our new limits. Okay, so first thing, substitute in the new limits. Then this sine squared x is just going to become u squared, yeah? And this dx just becomes du on cos x. Okay, so remember how I said always check this, you've substituted in at least 3 things. So limits, this, and the dx. All right, now we cancel. That just cancels with that, okay? And that just leaves me with this. Nice and easy to integrate. So it's going to be u to the power of 3 on 3. I can just take the 1/3 out the front. And now I substitute in 1 on square root 2 here, and with 0, it's just going to be 0 essentially. Now, 1 on square root 2 cubed, yeah, is just going to be 1 on 2 square root 2, isn't it? So multiplied by 3 is going to give me 1 on 6 square root 2. Okay? So you can leave your answer like that, but you can also change it, so rationalize it. So that's what we've done over here. We've just taken 1 on 6 square root 2 multiplied by square root 2 on square root 2. And with this, 2 times that 6 gives you 12 and square root 2 on top. But just note that it is okay to leave your answer like this without rationalizing it. But we do like to make an answer rational if we are able to or have the time to. All right. So in this one, you didn't actually tell you to let u equal to sine x. We had to work that out for ourselves. And you can see that with this, just remember the limits. Otherwise, this question was quite straightforward.